Alright, hello everyone. My name is Micha Franz. I'm working as a project manager in a GIS team inside the Department for Urban Development of the city of Zurich. I'm currently working on historical digital 3D models, a project that some of you may have already heard of at last year's user meeting when my predecessor Tobias Frey gave a first glimpse into it. And meanwhile, a lot has happened, and we published the first parts of the project, and I would like to share some insights with you about that. The project started 2 years ago and is running for another 2 years. We are now around half-time of the scheduled agenda, and we are currently working on the time period around 1500. In total, 6 time periods will be released, ranging from 1900 all the way back to the Neolithic 3000 BC. This project is being realized through a close cooperation between the City Archaeology and the GIS Competence Center of the City of Zurich. And the whole project was only possible by winning the innovation credit of Smart City Zurich back in 2020, which kicked off this project. Now, the goal of this project is not just to make a nicely looking model. It should also provide knowledge about the city's past. It should be accessible to everyone and present new gains in knowledge. And everything that's published is open data and can be used by everyone. And since it's a publicly funded project, this is a way of giving some of that back. And another for the city important aspect is that we are able to claim the thematic leadership of Zurich's past by providing and maintaining these comprehensive models. Here is an overview of the different time periods. As I said, we already published the first 2 earlier this year, namely the model of the Neolithic pale dwellings and the one from 1800 with its famous protective and massive walls around the inner city. And currently we are working intensively on the period around 1500, which is planned to be published next spring. And we have also just started to set the base for the Roman period, 200 Anno Domini. As you would expect, quite a few things you will see during these presentations are still in progress, but now to our main topic, which is of course CityEngine. So I would like to tell you more about why, and probably more interestingly for you, how CityEngine was used and involved in our project. There are different reasons why we chose to use CityEngine with its parametrical modeling approach in the first place. First of all, it allows us to efficiently create models for various time spans. And in the model of the time period 1800 alone, we had around 5.5k buildings. And out of these, only 49 had to be modeled manually. And everything else was modeled with our reconstruction rule that you will meet later on. Overall, it took one person 2 weeks to generate and adjust all parametrically modeled buildings, which is quite impressive for the number of buildings to cover. But of course, there went a lot of effort into creating a CityEngine rule that works this well for our cause. But then for the 1500 time period, we don't really have to adjust anything geometry-wise, which again saves us a lot of time. Then secondly, we wanted to have buildings of equal quality throughout the whole area of the city. In other models or illustrations, the focus always lies somewhat heavily on the center of the city, and the rural areas are a bit neglected and more in the background. But with this approach, we can include them very easily without much additional effort. And lastly, CityEngine allows us to update the model very easily if we have new findings. For example, new buildings or that a building looked different than we initially assumed. And we can simply change the 2D geometry of the footprints in ArcGIS Pro, and a Python script imports them into CityEngine and checks if the footprints are already existing, if they are new, or if they were modified, and then it deletes the obsolete ones. And this really assures that we always have a consistency between our 2D and 3D data, which is very important. So the general workflow for our buildings is that we receive some source data from the archaeology in the form of historical maps, images, or text descriptions. This is then turned into 2D data in the form of footprints in ArcGIS Pro. This can be a rather straightforward process if you have nicely georeferenced maps, but it can also be rather tricky if the maps are not that nicely or easily georeferenced because the scale is not correct, or if you have images or even text sources, and then there is a lot of knowledge needed to get realistic footprints out of that. So now we all know what a house looks like, but what does it really need to get a house or the house we are thinking of, especially if we are archaeologists or historians? Maybe the overall height isn't of much value, as we have no idea how high the building was anyway, but we might know that it had 2 stories, and we might also have quite a bit of information derived from still existing houses today on what room heights we can expect. But is there a need for various room heights regarding the first floor and everything above? What are the general rules for roofs? Are, for example, roof overhangs always larger on the front side of the house, or are they equal on both sides? I can tell you this much: for houses in the villages around the city of Zurich, this was indeed the case, as large roof overhangs was a sign for wealth, but no one actually had the money to do the same investment for the backside of the house. So we have this difference. So we see a house is not just a house, and especially not one that is a few hundred years old. But fortunately, there is a tradition of building research that dates back more than 5 centuries here in Zurich. And we have a good amount of knowledge on such historical buildings. And as I just said, there is quite some information around on historical buildings, but still it's needed to be collected and validated by those people that know this subject the best. And we were super lucky to draw on the extensive knowledge of our building specialists within historical sections of the urban planning department. Based on sketches, images, and existing footprints, we went through all the measurements that are common in building research, and we weighted these. And only the most defining ones should then finally make it into the reconstruction rule to keep the process as simple and as fast as possible. And of course, for each and every parameter, valid value ranges were defined. This was of greatest help because for many of the rural buildings, we really didn't have nothing more than the footprints from a historic map and very limited information on building types and facade materials. But in those cases, we already got quite close to the general look of such a small village by just using the reconstruction rule with its default values. And we were constantly struggling to balance automation, resemblance, and optimization. Of course, we wanted to have as much as possible automated, but this really works against resemblance, which would go more into the direction of having lots of control over every single building and adjusting every small detail. And the third factor is also very important for the further use of these models, as they are, for example, part of the digital twin in the city of Zurich, which can be accessed through a 3D web viewer. The greatest challenges we faced were the usability to enable non-3D users to be able to alter the geometry of the buildings to their likings. And this really involved a lot of testing, discussions on naming conventions, and tricky decisions at the automation versus resemblance front. Because a lower number of parameters will most likely result in something that is easier to work with, at least in the beginning. The footprints we are working with are also anything else than nice, rectangular, perfectly formed primitives. We have some weird angles, we have L-shaped buildings, and so on. So we needed a system that provides us with resulting houses and especially roofs that still make sense. The level of detail goes close together with the poly optimization. We want to have models that perform well in, for example, web applications and still have enough level of detail to make them attractive. But maybe the biggest challenge of all was expectation management. How do you tell people we don't have the resources to treat every house individually? Why is the window not exactly where we wanted it? And why can't we solve every single footprint and might have to actually slightly alter a footprint to make it work? These are very difficult discussions, I can tell you that. But we should not forget that the main goal of this project was never to have a one-to-one perfect model that accurately depicts how Zurich looked in the past. But we need something that is also easy to maintain and that just comes with a price regarding details. Here you can just see some of the first testings we did with different roof forms to see if they work with varying footprints like L-shaped footprints or some funny angles to see if they behave the way we want them to behave. And then this is an example of the final product of such a house with all these different parameters, which I will show in action later on. And as you can see, the building is already fully textured, which brings me to the second part of this process. In order to get historically accurate textures on our buildings, we first had to get an idea of how such houses around 1800 looked like, but also what the distribution of these different appearances could have been. For example, how often were half timberings or stone walls or wooden facades, etc. And for that, we used different historical views of Zurich. And the one you can see here is actually painted on an old oven from that time. So our archaeologists really used everything they found for this reconstruction process. Here we can see a view of the historical village of Albisrieden from around 1714 to 1816, and we can see different type of facades. We can see plastering in blue, we have some half timberings in red, wooden structures in yellow, and we have bricks on top of pretty much all of the buildings. And so views like that really gave us an idea of how often the different materials could have occurred. Here we just see a selection of the many different historical views that were analyzed. These were not just from the city of Zurich itself, but also of surrounding rural areas, since we could assume that they must have looked quite similar. We then created an overview of all the available historical views, and we counted the material occurrences in order to get a statistical evaluation. And all this information was then later fed into our reconstruction rule to get a realistic distributions for all of our textures. So now we gained an idea about how the distribution of different materials were, and now the next step was to find out how they actually looked like and how we can create a realistic looking texture out of that. And to get a collection of templates for these textures, our archaeologists took photographs from remaining buildings from that time period. And here we have different kinds of half timberings, for example. And out of these examples, a base texture was derived, which was then fed into the CityEngine rule to get the final houses or examples of final houses that you can see on the right-hand side. And here we also see a good example of the limitation of that approach, because the construction of the half timberings in both models would probably not hold up the check of an expert. But as I said before, this is not what we're looking for. We're not looking for a one-to-one accurate reconstruction, but we need something that looks familiar and we can still work with it. Here's another example, this time with different kinds of stone facades. And what's really cool about this approach is that it can be used for a different time period by really only changing the input textures. Of course, these have to get derived the same way as the ones that I've just shown, and this takes some effort. But the whole implementation of the texture afterwards in CityEngine stays the same, and we get buildings for a completely different time period without having to redo all the work that went into the reconstruction rule. So here the automation really shows its power for us. Now, I've talked a lot about the process of how the geometry and the textures were derived, but how does it look like when the rule is finally applied? This is what we see here. The building is initially generated with random parameters that are within these defined statistical values that I showed you earlier, so that every single house that is generated is made from historically possible composition of elements. But if we now have a more detailed information about a certain building, we can simply adjust these parameters, like the percentage of living area unstable, the type of roof, if the roof was symmetric or not, the number of floors, and also since we have a clear difference in rural and urban buildings, this was also implemented, and we can just switch the two styles. And following this approach, we can also let someone from the archaeology adjust these settings by themselves without having any prior knowledge about CityEngine or 3D modeling in general, which is very efficient for us. Apart from the standard buildings, which made out the majority of all 3D elements, we also generated various infrastructure objects using the same ready-to-use textures. Here, for example, we have a couple of bridges and the inner wall around the old town, and some buildings that were on top of the river with some poles. And lastly, we built around 300,000 trees for our models with very little effort, and which again are easily modifiable since the input data to these trees are really just points, and the result is a pretty realistic looking forest, I would say. However, the approach also has other limitations, and as I mentioned, not every single building was made in CityEngine. There are a number of buildings with a really high recognition factor, such as churches, like the Fraumünster that you can see here, or guild houses or monasteries. And the individuality of these buildings really made it impossible to include them into the general workflow. And therefore, for 1800, 49 buildings were actually manually designed and then added to the rest of the model. The final product of the first two time periods were published early this year, as I mentioned, and they are embedded in a publicly accessible web application called Zurich 4D. And here users can go through the different time periods. They can explore every edge of the city. There is also a split modus that lets you compare the different time periods side by side. And for each object in the model, there is factual data that's retrievable, and that gives you more information about that object, such as the source it was derived from, and the EGIT number, or if the building had a specific name. And last but not least, we engaged our friends at Urban to create renderings for the two periods, and these raise the models visually really one step higher and give a lifelike impression of the city. And I think I will just let you enjoy these impressions to finish off this presentation. All right, so that's it from my side. Thank you so much for having me. If you would like to get some more information about this project, feel free to visit our website through this QR code, and stay tuned for a little behind the scenes movie that's coming out very soon. Thank you.